Hey guys, it's Axiomatic Uncertainty here. This is my first video in a long time, but I figured I would do something cool, which would be a math video on the derivative of x to the x power. So first, we're just going to write this out. Y equals x to the x. I apologize for how bad my writing is with a mouse. I might do whiteboard videos in the future, but I don't really have a camera right now to do that with. So first, we're going to do the explicit method. Okay, and how we're going to do this is we're going to start off with y equals x to the x, right? And we can rewrite this as equals x, or e to the x ln x. And this is simply because we're taking this and rewriting it as e to the ln x. So e ln x. So that's pretty simple. Now what we're going to do is we're going to take the derivative of that. So we're going to say d dx of e to the x ln x, and this is going to be equal to e to the x ln x. So the way we can take this derivative is actually with the chain rule, because we do know that the derivative of e to the x is equal to e to the x, and so if we use chain rule, we can say e to... Gosh, I'm so bad at writing like this. This is my first video like this, though, so... You know, I'll improve, hopefully. So, e to the x ln x times, and then we're going to have to use the product rule. So, first, derivative of ln x is 1 over x, so we have x over x, which is 1, plus, right here, the derivative of x times ln x, which is just ln x, because the derivative of x is 1. And so now we have this. So we can actually simplify this to x to the x, because as you can see, whoops, let's just get a different color here. Okay, I don't know why that didn't select. There we go. Sorry. Oh my gosh. Okay, this is really annoying. Sorry, this is like my first time using this application like this. So, yeah, we got x to the x here. Actually, let's just highlight over that so you can see these two. And then we also have this section, which would be our other bit, which is 1 plus ln x. Okay. And that's the explicit way of finding the derivative. Now we're going to do the implicit differentiation. So just grab our color. Implicit is going to be just by getting, taking the logarithm on each side. So ln y equals ln x to the x. And because of the property of logarithms, we can bring this out to the front. And so we'll actually just have, you know, cancel this and just write x there. And so now what we can do is we can take the derivative on both sides. And this is just really simple. It's going to be derivative of ln y, which is 1 over y times dy dx. Okay. I'm already getting better at writing. As you can see, my writing has improved a bit. I tried a little bit before this. It was terrible, but it's gotten a little bit better. So now here, I'll just write this down here because we're running out of horizontal room. We're going to have to write this part using the product rule. So first we're going to do the derivative of x. Okay, so that would be 1 times, and then ln x plus the derivative ln x, which would be times x. Okay, so basic stuff here, you know, this one, derivative of x, which would be 1 times ln x, plus derivative of ln x, which is 1 over x, times x. Let's just close off these brackets. Now, as you can see, we don't need that. These two cancel, and so we're left with 1 over y. Wait, we're left with 1 over y dy dx, that was a sloppy looking dx, equals, and then, you know, 1 plus ln x, right? That's pretty simple. Let's just make this pretty clear. These are not related. So that is it. Now the last step is going to be to multiply through, so we're running out of space here, so I'll just do that. And sorry if this is getting a little bit unclear. Dy dx equals y, whoops, 1 plus ln x. And so all we've done here is bring over this y by multiplying. And now we have to simplify. And we can do this by realizing that this y is equal to our original equation, which would be x to the x. And so if our y is equal to this original equation, we can just say x to the x times our other part, which would be 1 plus and so that would be our other derivative. I like these Christmas colors going on here. And also here we found this, and those would be our two derivatives. So as you can see, this is the implicit method. This is more like a convenient, I guess, method of doing it. It's a lot less steps. It's prettier looking. But overall, you know, this is a much easier way to understand. And I know this is the way I first did it. And so, you know, that's the way you'd first think of, I guess. So that was the derivative of x to the x. If anybody's watching this right now, I don't know, you know, if I have any following for this channel. Math channels aren't very popular either, so either way, if you have any suggestions for future videos and like what kinds of derivatives and like integrals and whatnot you'd like to see, just message me in the comments below and I can see about doing stuff like that. So this was just the first math video. Thanks.